So I'm here to talk to you about the application patching manifesto, kind of a call to arms around dependency management, because I think we're doing it wrong a little bit. A little bit about me. It's a picture of me over at the green sand beach here on the island. Awesome place to visit. I am a static analysis enthusiast. I love SaaS tools. I love building things. As Jim mentioned, I am the founder of the OWASP Dependency Check project. In a lot of ways, that project predated a lot of the commercial tools that are on the market today. It was kind of, when I was showing it to people, they were always like, what the heck is this thing? And it's become very, very, very popular, and I'm kind of excited about that. So what are we going to talk about? Today, I actually have two fire talks for you guys. The first is the application dependency patching piece, and then the other half is about limiting the exposure to both new and unknown vulnerabilities. Unfortunately, the second half of the talk is very Java-centric because that's where I spend a lot of my time. So most organizations have patching programs. They focus very heavily on infrastructure, OS, middleware, networking, firewalls, etc. Their success rate varies from organization to organization. Some do very well at getting patches deployed ubiquitously across everything very fast. Others lag behind. But what about application dependencies? You know, if, Spring WebSockets. Thank you, Alvaro. For those that don't know, there's a new remote code execution that is been released for that. The POC, or the exploit code has not been released yet, though. But it's still something you guys need to patch if you're using Spring WebSockets. But what about those application dependencies? Generally, they're not included in any kind of patching program. If they are, they're just focusing on truly high-risk, known security vulnerabilities. And, I'll go in to show you why that's a huge fallacy and a problem for keeping things secure. It's the idea of compliance versus security. So, to talk about application dependencies, let's look at what applications are actually made up of. This is a slide from Contrast Security. They do runtime application self-protection. But I really like the iceberg here because it shows that you've got 21% of your code, at least in the applications they analyzed, 21% of your code is resting on 79% of third-party and commercial libraries. So that's the majority of the code that's being deployed. And their study also shows that in that 21% of the custom code, they find on average 26.7 serious vulnerabilities. Unfortunately, that shows that we have a long way to go as a security industry, with educating and providing better tools and architectures, secure by default frameworks, etc., so that those 26.7 don't show up. But that's where we are today. People who code are still introducing vulnerabilities. But what about those two vulnerabilities down here? I do like the fact that those two vulnerabilities are down in this section right here that is in the unexecuted code. Only 8.5% of these libraries are actually executed. And, they put those two vulnerabilities down in the unexecuted portion. That's a little bit of a fallacy or misrepresentation on the diagram, partly because these graphs, or this graph is a picture of what is actually deployed, not what is actually reachable. And when we talk about some of the exploits that are going on with some of the deserialization and things like that, all of this code is reachable. And in a lot of cases, those really critical CVEs are actually in the executed code. So to continue on why I think some of these two vulnerabilities are so important, and this third party, the 79% of the code is so important that we pay attention to, let's take a look at the National Vulnerability Database. Hopefully everybody knows what this is. It's a list of known security vulnerabilities and exposures. We've got things like the Spring Data REST vulnerability, had a remote code execution. Spring WebSockets had a remote code execution recently. These are some of the types of attacks that are most that I care about most. They're the most devastating because when somebody can just run arbitrary code on your server, it's pretty much game over. So, I mean, yeah, there's other attacks and things, but remote code execution is, in my opinion, one of the absolute worst. And, you know, not all CVEs are created equal. Some are, you know, it varies on your organization, information leakage, weak encryption, things like that. It varies. People debate about the scores. And sometimes you can have 3 or more low-risk CVEs, things that look completely innocuous, chain them together, and you've got remote code execution or some other critical vulnerability happening. So just because it's known, even if it's a low risk, you may need to be looking at it and thinking about, do we need to patch? Is this really going to affect us? Chances are yes. But the biggest thing about this is CVEs are public. Both the good side and the bad side have access to them. Commercial vulnerabilities like risk-based securities, VulnDB. It used to be known as the Open Source Vulnerability Database, or OSVDB. Great sources of vulnerability information. They do a ton of research on this. They've got something like 40,000 more vulnerabilities that are in the NVD, maybe more by now. But, you know, bad guys can buy subscriptions too. So, you know, my point is, if you're solely relying on the NVD, you're probably missing things. There's other vulnerability databases too, like the Node Security Project. There's a bundle audit that has, you know, things for Ruby that are not in the NVD, etc. There's a lot of vulnerabilities that are known that are not in the NVD. So, let's talk a little bit about this known CVE versus unknown or unreported risks. SNCC has a report that I'll talk a little bit more about in a slide or two. States that of the respondents to their survey, 25% of the respondents say that they do not report security vulnerabilities to their users. 25% just don't. The majority of them report that they'll put a note in the release notes about the security vulnerability and that you have to upgrade. Only 10% say that they open up a CVE. I mean, that's a very, very small number of vulnerabilities being patched that are actually reported as CVEs. So why is that such a huge problem? Well, this is one of my favorite CVEs to demonstrate this problem. Prime Faces. It's a JSF implementation. They have a weak cryptographic strength CVE, that's what they called it under the CWE, because it's actually a padding oracle attack that, when exploited, actually results in a remote code execution. This CVE was published January 3rd, 2018. They knew about this, fixed it, released the patch February 2016, almost 2 years ago. It's been out there, and this is not uncommon. Vulnerabilities are known for a long time, and it's either they're known for a long time and the fix takes a while, or the fix is there and nobody pays attention to it. And this happens over and over and over again. And so if we're solely focusing on these known risks, we're missing a ton of security. And what really makes this specific one great, as an example, is shortly after the CVE was published, crypto miners started exploiting this on sites and mining coins. And you can read about it at the blog post on the Prime Faces site. You know, it's just one of those where nobody really knew that this existed. The second it was published, the bad guys started attacking. So, when we come in to talk about application patching, some of the current state, some of the people that are doing the best, they're treating out-of-date libraries as part of their code hygiene, code quality. They're building time into their schedules to actually deal with this and upgrade things. They're using tools, in some cases not only to notify them of upgrades, but to actually just perform the upgrades, and I'll talk more about that in a second. Everyone else on this spectrum, you know, and some of this comes from the SNCC report, they occasionally sweep through the dependencies and do the upgrades. If they hear about it, they'll about a vulnerability, they might do an upgrade. But in general, some of the things I've heard from developers, they don't want to be the one to break the build. So it works, I'm not touching it, and from upper management, features are more important, I've got to ship code. So, to continue on the current state. From the SNCC report, the State of Open Source Security, 42% of people use tools to notify them of vulnerable libraries. I think that's awesome, that they're doing what to date has been we've been pushing as the state of the art. You are using software composition analysis tools like dependency check or one of the commercial competitors. But again, that only covers known vulnerabilities. So 37% of the respondents use tools to notify them of new versions. I think that's a travesty because every build system I know of out there, or anything that has a build system that has a dependency management framework, has tools to at least notify you of updates, and yet only 37% of people are using them. And then, of course, you have the 16% where they just don't bother upgrading. Avoid those projects. So this brings us to a discussion about technical debt versus security debt, because if people aren't upgrading, they're building some of their technical debt. Hopefully, everybody knows what the term technical debt. They're doing the easy thing now versus doing the right thing, because the easy thing is quick and easy. The right thing takes time. In this case, the right thing would be upgrading, whereas they're just staying status quo with their libraries. It's not broke, don't fix it. And so then we get into security debt. It's just a portion of your technical debt, but it has a lot to do with security preparedness. Are you doing proper testing? Are you doing software composition analysis? Things like that. The differences with security debt, specifically with these known vulnerabilities, if you don't pay your security debt, eventually the debt collectors will come by, steal your information, and sell it to the highest bidder. It's just kind of we've seen this happen over and over again with the breaches, people getting popped with known CVEs. That brings us to emergency patching. You had a remote code execution, Spring Data REST, struts. They've had 3 CVEs, remote code execution in the last year, prime faces, Spring WebSockets, all have remote code execution vulnerabilities. You have these applications on the internet, and anybody who can get access, or anybody who can ping them, can basically execute code on your servers. Now, why patching is difficult in most cases when we get into the application space is that a patch equals upgrade. There are a few teams, Spring being one of them, and the Spring group is doing an awesome job with this, where they actually backport the security patches to the earlier releases and have minor point releases. But there are so many libraries out there that do not backport the security patches. And so your only avenue is, to upgrade. And you may have to cross minor or major point or version upgrades, which could have significant breaking API changes and could take a lot of work to do this upgrade. And so when you have these emergency patching situations, again, your technical debt becomes security debt that has to be repaid immediately. Otherwise, you could end up like Equifax. And I talk a lot about software composition analysis and how I've talked to several people today over the last couple of days about software composition analysis. It's a great tool. We need to be doing it, and it's really great for that compliance checkbox. And it really helps the security teams because in a lot of ways, software composition analysis is the mechanism that security teams are getting a bill of materials for the applications that are deployed within our organizations. And if you don't have that bill of materials, if an emergency vulnerability comes out, do you know where it's deployed? Do you know what applications are using that? Yes, I'm hoping teams are just upgrading anyway, but you still have to ensure from a security team standpoint that these upgrades are happening. And sometimes these inventories are very difficult to know. I mean, what is exposed to the internet? I've seen companies talking to me about this problem, and they've got UAT systems deployed to the internet that were completely missed in the patching frenzy because it was UAT. And yet that is an exact entry point into the organization. So where are we going with what I'm hoping to be some of the future state in application patching or application dependency management? We convince teams that upgrades just have to be part of the SDLC. And I'm going to talk about some techniques on this one. But it has to be planned as part of the SDLC. And considered old libraries or dead libraries need to be considered a code quality, a code hygiene issue, and treated with equal respect as all your other bugs. Because by maintaining these things and keeping them up to date, you're fixing your unknown, unreported vulnerabilities. That in a lot of the FOSS, if the bad guys wanted to go audit that code, they may know about them, they may be exploiting them. And nobody knows that they're there because many eyes has not been the security panacea of open source that people were hoping. So, one of the big things is teams have to start using tools to notify them of upgrades. Like I said a little bit ago, every dependency management tool, most of the build frameworks have these tools to notify you of new versions. But we have to get people to be upgrading, not just for known security issues, but for just point releases, minor releases, functional additions to the application. And yes, that sounds difficult, it sounds daunting, but the technology is coming to make this a lot easier, and we have some of it today. Doing this by just making the upgrades as part of your SDLC, what this does is it just becomes natural habit for the development teams. And I've seen this from some development teams. They keep things up to date all the time, and new emergency vulnerability comes out or new problem comes out, they just roll and the next version's out there. No big deal to them. Whereas other teams that have been building up their technical debt, they have a lot of problems. They have regression testing, integration tests, all their test suites have to run, and they're not used to doing this in just for upgrading their libraries. So get it ingrained into the SDLC. To do that, there are some fantastic tools. Some of these things are relatively new. Over the last couple of years, they've been coming out. The top 1, 2, 3, 4 here are actually GitHub applications. Dependabot, all 4 of the top ones here, PyUp, Greenkeeper, Renovate, Dependabot, depending on your technology stack. All of these things, new library comes out, you're going to get a pull request. That pull request, if you've got your GitHub repo set up correctly, will then kick off your continuous integration in Travis or whatever CI you're using, run your integration, compile, run your integration tests, and if it passes, merge it. It becomes a no-brainer because your development isn't having to do anything. You're just, the bot submitted a pull request to fix bugs. Great. I love seeing things like this. The bottom 2, specifically GlideBot is something I just found out about this week. It's a tool that you can run locally for your Go applications. The Maven versions plugin, I love this one. Most versions plugins, like the Gradle versions plugin, they'll just give you a report, and that's what most people use them for. They just give you a report of the libraries that need to be upgraded. However, this plugin will actually upgrade your libraries for you. You can configure it just to update your POM and update the libraries. It's really awesome. I've been using Dependency Check for a while. So let's get into transitive dependencies. This is why patching is hard. Because you've got things like Apache Struts that uses Jackson data bind. Jackson data bind has a deserialization bug. Well, what if Struts didn't upgrade very quickly? Well, then you can rewrite your application, or you could, submit a pull request to Struts to upgrade the library and, own some of this responsibility yourself. But This is why, FOSS is nothing's ever really free when it comes to FOSS. I want to point out a couple of things here. GitHub, with their security alerts, has been doing a fantastic job. I love this feature that they've implemented, where they're alerting people when they're using known vulnerable libraries. Again, I'd like to see them alerting people when they're using out-of-date libraries, because those out-of-date libraries may contain unknown vulnerabilities that have been patched. But still, it's a light years ahead of where we are. It's fantastic that those guys are out there doing that. One thing that a lot of people may not know about is actually Operation RoseHub. This is back in 2017 when the Apache Commons vulnerability came out. The Mad Gadget was one of the original, devastating deserialization attacks. 50 Google employees, grassroots effort, went out and patched submitted PRs to 2,600 projects out on GitHub. Completely grassroots. Googlers who were involved in this, I can't thank you enough. I mean, this type of work is awesome. But again, this is all reactionary to known vulnerabilities. So we can do better. So if FOSS is critical to your organization, this is some of the call to arms. Be proactive, contribute back. Even if it is just helping them keep their dependencies up to date. When you do this, though, you have to go all the way down in the dependency tree to everything that if you use struts, you have to go all the way down in the struts dependency tree and help every layer of that keep up to date so that we can be using everything up to date in struts. Or Spring. Spring does a good job. Dropwizard does a good job of this. There's several that do a good job of this, but there's a lot of libraries out there that don't. And that's some of where we get into some of those transitive dependencies. And this is where patching, wait, did I go backwards? I hit the wrong button. Sorry. And so that brings us to the next side of the talk. When patching isn't fast enough, when Alvaro's struts vulnerability was published and somebody published a POC against it, the POC was published within, hours, if not less, right? So teams would have to go through their entire patching and release cycle in hours or less. Otherwise, their struts applications on the net could be popped and remote code execution. So what can teams do? WAFs, virtual patching. Might work, might not. It'll probably work against the published POCs, but they might be bypassable. I've seen a lot of work done on bypassing WAFs. Even, it's the cat and mouse game. What about this new bolt-on panacea of runtime application self-protection? We can all go home, right? Oh. Okay. Well, some of these may provide some fantastic protection against these vulnerabilities. The remote code execution type things. But it all depends on what libraries you're using, what frameworks you're using, etc. May work, may not. Again, depends on the vulnerability and depends on what code you're actually using. You may have to wait on the vendor, just like with the WAFs and the virtual patches, depending on your expertise. You may have to wait on the vendor to provide a patch, or not. You might be able to write it yourself. So, but, some of the advantages, they can block some of that low-level OS command injection just out of the box. Some do a better job than others. So, other alternatives. One of my favorite things that I've seen is I actually saw a group, unfortunately they didn't open source this, one, there is the not-so-serial, which is the original Java agent was used to protect against deserialization attacks of core Java deserialization. It's no longer maintained, it's Java only, and it, like I said, it's only the read object in core Java deserialization. It doesn't cover any of the other frameworks. I've seen a team, external to my day job, but I was talking to, they actually showed me that they had a single-purpose RASP they basically extended some of the concept of not so serial to cover Jackson, Xstream, Cryo. There's like 15 deserialization libraries that they had extended, or they had rewritten a tool to block so that they could do blacklist and whitelist for these different frameworks. They also just flat out blocked Process Builder and said, if we have an application where the developer needs to run Process Builder on our web application, well, we need to fire an architect, or at least do some training. So that was a really great idea that they had, because 90% plus of the remote code execution, even though you might be able to be injecting Java, 90% of the POCs still drop down into an OS command injection, hitting like the Process Builder. And so they blocked the Process Builder, and even if they were still vulnerable to whatever the OGNL, deserialization, remote code execution attack, because they were also blocking the Process Builder, 90% of the POCs failed. And even though an attacker could have tweaked the code to do something else malicious, it looked like it failed because they blocked the Process Builder, and it's kind of an unneeded call in 99.99999% of web applications. So that's an alternative that you could do. You could take a similar approach and create your own single-purpose RASP.
Are they blocking the Process Builder with the deserialization mechanism, or with the Java Security Manager?
Okay, the question was, how are they blocking, or how are they doing some of this work? How are they blocking the deserialization? How are they blocking Process Builder? They're using a Java agent that rewrites the bytecode, and anytime that you see a call to Process Builder, it just threw an exception. So other alternatives, of course, everybody should be doing defense in depth, but here's one of the big things that, again, talking with my work with Dependency Check, talking to people, one thing that I see people miss a lot is that the web root is still writable. Why? This is one of those things that a defense in depth, you should be doing proper server hardening, but this is one of those where, because the web root was writable, they were able to chain 3 CVEs together to get a remote code execution in access. And so it's just really go through and really harden your environment, especially your Docker containers. It's Docker, yeah, you could wipe the machine and just spin it back up, or whatever containers you're using, but harden it from the beginning, because if you didn't harden it from the beginning, however they popped it the first time, they can just come back and pop it again. So really concentrate on defense in depth. Other ideas, and these gets into some of the more novel ideas in Java. The maven-shade plugin. There's other shade plugins in the Java world for Gradle. Basically, this is used by Java developers to deal with jar version conflicts. It's a way to make your deployment easier, because you can take Apache Commons and at compile time, take all of the classes from org.apache.commons, rename them my.project.commons, and bundle them into your jar. Just runtime. This is a very common developer tool. A lot of people actually do use this, even though there are debates whether or not you should. Not everybody likes it. Some people do. But it's an interesting idea from a security standpoint, because if you did have a code injection vulnerability, attackers are expecting the gadgets to be in the known package space. And if you just moved them to a different package space, an attacker can't execute them, because they can't inject and call something that they don't know what it's called. Now, this is just doing a static replacement. It's entirely possible in your build system that you could dynamically generate that name every time you build it, and so even your developers deploying the code wouldn't even know what the runtime name is. So it's another interesting idea on ways to change your attack surface. So back to the iceberg. If we've got 70% of the code that's never executed, why are we deploying it? I mean, really, we've got the maven-shade plugin. This is the only one of the shade plugins that I know that has this feature. It actually will analyze your application and say, that class is not being used, I'm going to throw it away and it's not going to be part of the deployed jar. So you can just remove all of that 70% of the code. You may remove the vulnerabilities. You may not. That's why it's all defense in depth. So I did that. I actually took those last two techniques with the maven-shade plugin. I took an old version of Jenkins that's vulnerable to one of the original, well, actually it's a vulnerable to the Mad Gadget Apache Commons vulnerability. So really quick, I just have a Jenkins instance here. It's up and running, and oh, can we not see that? Oh, I know what's going on. Sorry. Go. Yeah, I know. It's a Mac. Thanks, Jim. The rest of this talk won't take very long. Sorry.
Go to settings.
Settings? Sorry, just do it quick.
I got this. Drag it to the right. You can trust me.
Yeah, no, you're good. I just recently switched to a Mac. I apologize.
What's your password real quick?
Got it. Cool. Sorry about that. Okay, so anyway. I'm still not sure I like it. That whole enter renaming things is, I don't know, it's confusing. Anyway, so this is just a Jenkins instance up and running. It's actually usable. I've done some testing with this. But if we jump over here, this actually executes the deserialization attack against this. And this is just your standard, attack, who am I, root, ls, you get the idea. I've got a shell. So what if, kill this one, and I spin up the shaded version, the version of Jenkins that has all the same vulnerable components. The only thing I did is I added the shade plugin. My first time doing this, it was a little, it took me about 2 hours to get Jenkins to work like this because there was a few intricacies I had to work through. And some of the code that the shade plugin thought wasn't actually used, it actually is because of various dynamic features of Jenkins. So we have the new version of Jenkins up and running, and if I try and run that same exploit against this, I get the finished success, but there's no shell. It still got the 500 error that it expected back because it was a bad request, but the exploit didn't go because the gadget wasn't actually there. So is that going to work or is that going to fail? Okay, good. So that's going to fail because we've got settings still up here. Yeah, no, it's all good. Okay, so in summary, patching is hard, but if we make it part of our SDLC, we can really solve a lot of problems by patching not only the known risks, but we can also patch the unknown risks. We have to be using tools. Ideally, we'd be using continuous automated patching via GitHub applications if you're fortunate enough to be able to use those depending on your technology stack. And I want to see more of these come out. Of course, there's standard defense in depth. Consider using RASP, even if it's just a single purpose. Some of these technologies are very interesting and helpful, but they're still very early days, and that's why I like the single purpose RASP as well. As opposed to the full-fledged, we're going to protect against everything. Let's just focus on something that is truly critical. We're going to pop our servers if these remote code executions occur. So a single-purpose RASP is actually not a bad idea. And lastly, if possible, depending on your technology stack, consider what's being deployed and does it really need to be there. The maven-shade-plugin, as you saw, can be used to change or remove some of your attack surface. So with that, I think, am I on time? Good deal. So, questions? Pretty much. That is pretty much what I'm saying. Jim just said, summing up the talk, instead of just looking for known insecure libraries, just keep the entire stack up to date all the time. The critical piece to this, though, is contributing back to the FOSS community. This is really where we have to engage on this topic, because if we're not keeping the dependencies of our applications up to date, if we can't keep the dependencies of our dependencies up to date, the transitive dependencies, there's no way that we can keep our applications up to date.
So going into that statement of updating your transitive dependencies, or the open source transitive dependencies, one of the problems we stated was that a lot of libraries are in fact patching.
Correct.
For example, there's a vulnerability in 1.2 of Spring, and how can we do that if they aren't back patching? Or is that another thing that we need to do, is force them to back patch?
While backporting the security fixes would be fantastic, I'm saying I don't really care about your security fixes. I'm saying, well, I mean, I care about them. That's why I'm talking about this. I'm saying that instead of having to worry about backporting the security fixes, I'm saying there's a huge population of FOSS community out there that doesn't even report when they fix a vulnerability. How do you know that they fixed a vulnerability? So I'm saying keep everything up to date, or as much up to date as possible. Actually, with dependency check, that's one of my problems, is somebody did comment on this in dependency check that I have some very old libraries. And that's because I have Java 7 users, and I have to maintain Java 7 compliance, and so there are a set of libraries that I can't upgrade because they were compiled with Java 8 or higher. This summer, when Jenkins, I believe Jenkins will be dropping support for Java 7, I believe that's going to be happening. You'd have to go read their website to be 100% sure on that one. But at the same time that they do that, I'll be dropping support for Java 7 within dependency check. And so then I'll be able to upgrade a lot more libraries. So there are issues with doing this, but keep as up to date as possible is really the call to arms around this. So,
review everything that we're using, I'd like to think that we're at least paying attention to that. So
we aren't.
Semi-automated thing where at least some human eyes go over something and say, is that something that people on the security team need to review?
And that is, okay, so the question is a concern about just fully automated updates. And, I'd be concerned too if I was allowing a fully automated update just to merge directly into master. That's not what these tools do. Well, like the Maven versions plugin could do that, but you'd have to physically check that into master after it did the upgrade. With the GitHub applications that are doing this continuous updating for you, it's a pull request. It's not merging into master. Your development team still has to review it. They can look at it and see, did the license change? That's the one other issue with just keeping everything up to date all the time, and where the commercial software composition analysis tools come into play, is somebody may change a license on you. It's happened. And if you then went to production without having monitoring on this, you could run into an issue. Last question, I think, because of time.
So it seems like, the concern about automatically submitting like a PR request, that sort of thing, is maybe lessened if you have really good unit tests.
Absolutely. The concern with doing any of these automated updates and whatnot really rely on having a really good test bed of unit integration testing all built into your CI. But in a lot of ways, that's just what you need to be a good development shop, period. If you're not doing good testing in your CI, you're bound to fail. Well, thank you.
Quick note, Jeremy, before you head out. By the way, when you're a quick ethical note about conferences, right? When you're a master of ceremonies introducing a good friend of yours to speak and call him an SOB, that makes you the SOB. Sorry. You are one, but I shouldn't have said it. All right, so, by the way, we're having lunch today in just a moment. The lunch that we're serving today is the actual LocoMoco. It's the meal, the LocoMoco meal. This is, first of all, what does the word loco mean in Spanish? Crazy. It's Portuguese, Spanish, and Hawaiian pidgin. Loco means crazy. You're all AppSec people trying to manage or build secure software. That makes you all crazy. But to counter that, we're at least serving you comfort food to bring some comfort to your lunch. So please enjoy traditional Hawaiian LocoMoco, and we'll be back in about an hour and 20 minutes for our next talk. Thank you very much, everyone.